So in this video, I want to talk about converting from the lowest structure to ultimately the condensed structure and then the bond line structure, okay? So if I'm looking at lowest structure, I'm saying, okay, well, what is the condensed structure for this, okay? Well, it looks to me as if I have so the condensed would be, I have a CH2, okay, which is right here. I have this CH2 here. I have a CH2, okay? It looks to me as if I have a CH, okay, and I have a CH2 that has an oxygen sandwiched in between, and the CH3 at the terminal end. Okay, so how would we represent this as a bond line structure? Okay, how would we represent this as a bond line structure? Well, at the end, I see a CH2, and I have this alkene functional group here. So the bond line structure for this would be, as present, I have a CH3. Okay, at the end, if I draw my double bond, this represents a CH2, which is exactly what we have. Here's your double bond. Here's my carbon that has one hydrogen, okay, and this is bonded to a CH2. Okay, so here's my CH2 that I will form join my oxygen. Okay, so there's my CH2. I have an oxygen with a CH3. Okay, so notice I have my CH2, I have my double bond that's bonded to, here's my CH, I have my CH2, I have my oxygen, I have my CH3 at the end. Okay. What about this? Okay, what would be the condensed structure for this? Okay, it so happens that with cyclic compounds, it gets a little bit tricky, okay? So notice, because I'm not in a chain, I'm in a cyclic compound, I can't write this as, how I would do this, okay? There's no way to do it, okay? So in fact, the molecular formula will actually be its condensed structure. And so if we look, we have 1, 2, 3, 4 carbons. So this is C4. How many hydrogens do we have? Well, we have 1, 2, 3, 4, 5. All right, so we have what? We have one hydrogen, 2, 3, 4, 5, 6. And let's put, I forgot one, so let's put one here. Okay, so there goes my nitrogen that would satisfy the octet rule. So we have 7, so this is H7N. Okay, so we have 1, 2, 3, 4, 5, 6, 7 hydrogens. So this is C4H10. Now, as I said before, this gets a little bit tricky, okay? Because without the condensed, without the lowest structure, you cannot just give me the molecular formula and ask me to draw the molecule, because we have what are called isomers, okay? And so they're essentially different structures but the same molecular formula, okay? So you got to be careful. So with cyclic compounds, we actually will use the molecular formula to represent, in this case, this. Okay, so what would be the bond line structure for this? Well, again, it's in the ring, and it seems as if we have a 5-membered ring. Okay, we have a 5-membered ring. We have our nitrogen. Okay, there goes my carbons. Here goes my double bond. Okay, and that would be the molecular structure. Oh, I'm forgetting my H. Okay, so we got to show our H explicitly on the nitrogen. Okay, so remember that. And maybe I should draw a bond here. So I gotta show my H explicitly on the nitrogen. Okay, I have to. Okay, so let's look at this one. What would be the condensed structure for this? Okay, well, it looks as if to me I have a CH3, I have a CH2, I have an O that's sandwiched in between. And let's see, I have a pattern here. So I have 1, 2, 3. So I have 3 CH2. So in fact, I could actually put my CH2 in bracket and condense it, saying that I actually have 3. Okay, so I have 3 CH2s, and then I have a CH3 at the end. Okay, so how would we represent this as a bond line structure? Well, again, I have a CH2. Okay, so I have CH3 at the end. So there's my CH3 that comes from here. Okay, I have this that's bonded to an oxygen. Here goes my CH2. So I have my CH3, my CH2, which is right here. I have my oxygen. Now oxygen is bonded to a CH2. Okay, bonded to a CH2. This CH2 is bonded to a another CH2. Okay, this CH2, which is right here, is bonded to another CH2, and then we have this CH3 at the end. Okay, so this would be the bond line structure for that molecule. How about this one? How would we represent it as a, as the condensed formula? Okay, well, if I look very carefully, I have a carbon that has two methyl groups, okay, or two CH3s around it, and I have a hydrogen. So again, we could condense that and rewrite it in a fashion where we have a CH3, we have two, right? We put in parentheses as a branch. We have two that's bonded to a carbon with an H. Okay. So notice how I just did that. This way signifies that I have this carbon that has a hydrogen and two CH2 that's bonded to it. Okay. So now I have a CH. Okay. I have a CH. Okay. So there's my CH, which comes from here, and I have another CH, which is right here. Okay. I have another CH. And also have another CH. Okay. So I have a CH. I have a CH, which is right here, and I have another CH. So I could draw this as being double bonded to the CH, which has a CH3. Okay. So again, and this is another important point I want to point out. You could also stick in a double bond or whatever every once in a while. Okay. To represent the condensed structure, you just got to make sure it's. If I look at this, I'm not saying, okay, well, this is a Lewis structure. This is condensed. Okay, so how do we draw the bond line structure? Well, I'm going to start from the central carbon. So you can see that I have a carbon. Okay, I have a carbon that has two methyl groups on it. So if I'm looking at this, if I draw something like this, well, maybe this represents. I'm sorry that you guys can see that. So maybe this represents this carbon. Okay, and there's my two CH3s. Okay, and it's bonded to a CH. Okay, it's bonded to a CH. Okay, so it's bonded to a CH, and it's bonded to a CH. Well, what do we have that will make it a CH? We have a double bond. Okay, so notice that this becomes a CH. I have my carbon that's bonded to two methyl groups, and there's one of my implicit hydrogen that I did not show. Okay, so now that I'm in this case, all I'll do is just represent my CH3. Okay, so notice my central carbon has a hydrogen, two methyl groups. I have a CH, which is right here. I have another CH, which is right here. And then I have my terminal methyl group, which is right here. Okay. What about this one? This functional group is called an alkyne, carbon-carbon triple bond. Okay. So again, if I'm looking at this, I see that I have a CH3. And okay, so I have a CH3. Okay, I have a CH. Okay, I have a CH. Yeah, so I have a CH. So I have a CH. I have a CH3. I have a CH. I'm gonna represent this with the CH3 being branched. Okay, and this has a carbon. This has a carbon. Okay, that's double bonded to a carbon that has a hydrogen. Okay, so notice what we did. We said this was a CH3. We have our CH and we put the methyl group because it's branched in parentheses, and then we have a carbon-carbon triple bond, which is a CH. Okay, so how would we represent this as a how would we represent this as the bond line structure? Well, this is kind of a bit tricky. Okay, so I have a carbon here that has two CH3s. Do you see that? I have a carbon that has two CH3s around it. Okay, I have a carbon that has two CH3s around it. Okay, so maybe I could draw this as something like this. Okay, I have a carbon that has two CH3s around it. Okay, and this carbon, okay, this carbon is bonded to a carbon. Okay, and I'm going to explain this in a bit. It has the hydrogen. Now, some of you might say, what the hell is going on? Okay, for for an alkyne carbon-carbon triple bond, the end of each double bond represent my carbon. Okay, so this point here represents this carbon. This point here represents this carbon. Okay, there goes my CH, which is right here, and it has a CH3, which is right here, and a CH3, which is right here. Okay, so this one is a little bit tricky, and it gets tricky with alkynes too. Okay, so remember that the end of each bond on an alkyne carbon-carbon triple bond represents a carbon. Okay, so how about this one? Well, again, we see that we have an oxygen, a carbon that's double bonded to an oxygen, and it has an H. Okay, and then let's see, we have two CH2s. Okay, so we have two CH. So we're going to put that in parentheses as 2, and we have a CH3. Okay, so that's how we would represent. That's how we represent the structure, the condensed structure for this. Another way, and I think the more common way would do it is actually to draw a carbon-carbon oxygen double bond, have our CH, have our CH2. Okay, have a CH2, have another CH2, and then our CH3. So this will also work. Okay, and in fact, I would actually go with this one. Okay, so this one is more common, but again, the idea is that we want to get it as condensed as possible. So this would be the condensed structure. Now, what is the molecular structure? Okay, or the bond line structure? Well, again, we have an H that's bonded to a carbon that's double bonded to an oxygen, and we have a CH2, CH2, and a CH3. Okay, so that would be the molecular form, the bond line structure for that molecule. And that's it for this video. Again, nothing more hard. Again, it gets a little bit tricky with the condensed structure, but again, as long as you get it in some sort of fashion like this where I could read it and be able to come up with the Lewis structure or the bond line structure, or the bond line structure, is fine. But you can see that actually there are two different ways of drawing the condensed structure for this.